Okay, so welcome back to my new video. This video it's a very special video because it has a lot of technicalities in here. So I'll encourage you to pay close attention to whatever I'm going to say. So what is a volume? On-disk files in a container are ephemeral. Okay, so when they say a volume is ephemeral, it means that that volume follows the pod lifetime and get created and deleted along with the pod. So these pods can be stopped and they can be restarted without being limited to where some persistent volume is available. So this presents some problems for non-trivial applications when running in containers. One problem is the loss of files. You can lose files when a container crashes. The kubelet then restarts the container, but with a clean state, meaning that it's going to wipe off all the data on that volume. And then the second problem occurs when sharing files between containers running together in a pod. So the Kubernetes volume abstractions solve both of these problems. Okay, so now we are going to define what a persistent volume is. A persistent volume is a piece of storage in the cluster that has been provisioned by the admin or dynamically provisioned using storage classes. Okay, storage classes, another thing that I'm going to talk about in future videos. It is a resource in the cluster, just like a node is a cluster resource. Persistent volumes are volume plugins like volumes, but they have a life cycle independent of any individual pod that uses these PVs. This API object captures the details of the implementation of the storage, be it the NFS, and then cloud provider specific storage systems. Now, what is persistent volume claim? It is a request for storage by a user. It could be a developer, it could be whoever has access to that cluster. Okay, so it is very similar to pods, and pod consume node resources, and then PVCs consume PV resources. So what it means is that pod consume node resources, and then PVCs consume PV resources. Okay, so pods can request specific level of resources like CPU and memory from the node, whilst claims can request specific size and access modes. Okay, and these can be mounted, okay, into your pod. Okay, so there's this access modes like read write once, read only many, or read write many. So in the next slide, I'm going to talk about this access mode, what each of them means. So in the middle of the slide, you can see we have a kind, a manifest definition called kind, and the type is what kind, and it's called persistent volume. Okay, and then it has a meta name, and then it has a capacity. The capacity has a storage of 5 gig, and then the volume mode is a file system, and then access mode is read write once. Okay, I'll talk about it in the next slide. And then you see we have another option called persistent volume reclaim policy. So these reclaim policies are retain, recycle, and delete. So I'll tell you more about this. So retain, it's obvious to retain something on a disk. You want to keep it on the disk. And then recycle, you are recycling something. It's also straightforward. It's like you are recycling your file system or your disk space. Okay. So that is also obvious. And delete. So the reclaim policy is also to delete everything on the file system. Okay. And then the storage class name, you could have slow, you could have block, yeah, so, or manual. Yeah, you could have slow, and then you could have manual as well. So there are things that I'll be talking more in future videos. And then if you look at the persistent volume definition, persistent volume claim definition, you see that we have access mode as well, the meta name, the volume mode is what? Block. As you see on the persistent volume, the mode type is for file system, and then the claim definition has a block. So what you need to do is that once you define a persistent volume, it has to match the attributes of the persistent volume. So what do I mean by that? The access mode, if you put read write once here, it could be a list. You could have a list of them, but if you put read write once here, you have to also put read write once here. Or if you put read only many and then read write once, you put them here, and then you put them read write once and read only many also here, because it's a list. You can put a list of those access mode. And then you can see resources, and the persistent volume claim is requesting for a storage size of 10 gig. Okay, but this is not going to make any sense because the initial volume is 5 gig and you are requesting for 10 gig. That is not going to be possible. So let's take it that the administrator created 3 volumes. Okay, one volume, the green one is 1 gig, the yellow is 5 gig, and then blue one is 10 gig. So the admin is going to create those persistent volumes, and they are sitting in your cluster. Okay, and then a developer comes in. These developers can claim a persistent, they can claim a persistent volume. Okay, so this developer is running two containers. One is file parser, and then the other one is web server. Okay, and then this developer is trying to claim 8 gig of volume for this pod. Okay, so the persistent volume claim will look through these 3 volumes and see which one fits. So you can see that it can claim 8 gig out of the 10 gig. And then it's going to mount, Kubernetes will mount that 8 gig inside the port definition. Okay, so you claim it, and then Kubernetes will help you mount it inside the port definition. Okay, so that is basically the flow. So let's take note of this. You can have external volume or a cloud storage that you can mount into your Kubernetes clusters. Okay, you can also have, let's say, NFS server and mount it inside your Kubernetes cluster. So these storage spaces are outside the Kubernetes clusters. You can mount them from anywhere into your clusters. And also note that these are external plugins to your cluster, and they could have different volume types. You could have different volume types inside your clusters. Okay, it doesn't have to be one type of volume. Okay, so if you look at the Kubernetes documentation, you will see different type of volumes that you can mount or use as a plugin into your cluster. And you could also have different containers that are consuming from different volume types. Okay, so you could have, let's say, file parser consuming from a cloud storage volume, and then the web server consuming from NFS server. Okay, so you could have different containers that are consuming from different volume types. And remember also that volumes are not namespaced, but they are available to the entire cluster. So take note of that. They are not namespaced. Okay. They are global to the entire cluster. Okay, so so these are the types of persistent volumes that I was talking about. We could have AWS Elastic Block Store. You could have Azure Disk, Azure File. You could also have GCE Persistent Disk, host, path, local, NFS, RBD, vSphere volume. You can have a bunch of them. So depending on your use case, you go for the type of volume you want. And then remember, I promised that I'm going to talk about the access mode. So when you say read write once, it means that the volume can be mounted as read write by a single node, just a single node. Okay, this read write access mode can still allow multiple ports to access the volume when the ports are running on the same node. Okay, so I think it's explanatory. The read-only many means that the volume can be mounted as read-only by many nodes. Okay, so you could have many nodes, like 3 nodes that are doing read-only on those volumes. Okay, that is also self-explanatory. And read-write many, meaning that the volume can be mounted as read-write by many nodes. Okay, that's why you have read-write many. Okay, read-write by many nodes. And then the read-write once port, meaning that the volume can be mounted as read-write by a single port. Okay, you use read-write once port access mode if you want to ensure that only one port across the whole cluster can read that persistent volume claim or write to it. Okay, so that is also another type of access mode that you can explore as a Kubernetes administrator. Okay, so enough of the talking. I'm going to switch to my terminal so we can do some practice. Okay, so currently I'm in my terminal. I'm going to check the node that I have. Okay, so I have two nodes running. Before I forget, I have one more slide, so let's go have a look. Okay, so I have 3 manifest files here. And then the first one is a port. The kind is what? A port. It has a name. It has a namespace. The container has a name, tax PV container. The image is what? Nginx is running on port 80. The name is HTTP server. The name is HTTP server. Okay, so let's leave that. And then we have a persistent volume. Then it has a name, tax PV volume. The namespace is fraud. And then it has a label, local, type is all local. And then under the spec section, you have a storage class name called what? Manual. And then the capacity is what? 2 gig volume that we are creating. Okay, just like the blue, green, and yellow of volumes, but this time it's just 2 gig. Okay. And then the access mode is what? Read, write once. And then the host path, okay, is mount/data. So it means that if the volume is the 10 gig option, the path on that volume is what? Mount/data. Okay. And then looking at the persistent volume claim, you see it also has a name called tax PV claim. It has a namespace called fraud. The storage class is manual. So as you can see, the storage class should match. Okay, it should match. It should be the same. The access mode also has to be the same, but you could have a list of those access mode. Okay, like the read write many and rewrite once. Okay, you can have a list of them as I explained earlier on. And then this persistent volume claim is requesting for a storage size of 1 gig. So out of the 2 gig, we want the PVC is requesting for just 1 gig. So it's more or less like this is 2 gig, and then the developer is claiming just 1 gig out of the 2 gig. Okay, just an example. But some of these volumes, if it's very small and then I request for just 1 gig, it's still going to make use of just all the 2 gig. It happens most of the time. You realize that if you are requesting something very small and the initial volume is also very small, it will just end up using everything, all the 2 gig. Okay. And now let's come back up. So as I said before, once you request for the volume, you have to mount it inside a pod. Okay, so once we are requesting for 1 gig here, we have to mount that into our pod. So here is our pod definition. And then the volume name, the name of the volume inside our pod is called what? Tax PV storage. So this volume right here inside our pod is called tax PV storage, and then it's claiming the persistent volume claim from this definition, tax PV claim. Okay, so it's just claiming, and then once it claims from this volume, it will mount it inside the container. Okay, so once you mount it, you reference it by the name tax PV storage. So you see that these 2 names have to match. Okay, so let me see if I can edit this. Okay, so this name has to match. Okay, and then it's claiming from this definition tax PV claim. As you can see, tax PV claim, and then it's mounting that into the container. Okay, so and then under this container, we are creating a mount path. The mount path is what? User share Nginx HTML. So it's going to create a path for this persistent volume claim of 1 gig. Okay, inside our pod definition. Okay, so I think that is all for now. If you still have any issues, please don't forget to leave a comment, and then I'll explain further if you still need help. But I think I've done my best to explain it. Just for the first time, you might not get it, but listen to the video again one more time, and I think it will sync very well. So now let's switch back to our terminal. Okay. So I'm going to cut PV pod. You see, the same definition as we saw before. Nothing new. I'm going to cut PV hyphen volume. Okay, the same definition. We have 2 gig. And then the persistent volume reclaim policy is what? To retain. Okay, we could also change it to delete or whatever we want, or recycle. We can. So what retain means is that if the port dies, whatever we stored on the volume should be maintained. It should be retained on the volume. It shouldn't be deleted. So when the port comes back, the port is going to attach itself back to the volume again, so that you don't have data loss. Okay, but in a case where it's supposed to delete, once the port dies, then everything should be deleted from the volume or something like that. Yeah. So I think that is that for that. And we can also look at the claim. Okay, so you see the claim definition also is the same. We are requesting for just 1 gig, but as I said before, it can consume even all the 2 gig. So let's see what we'll get. The access mode is what? Read write once. Okay, so we are going to run these 3 YAML files. So I'm going to start with the persistent volume first. So meaning that we want to create a volume first. So the volume should be readily available before we create, and then we create our port, and then we can now write the persistent volume claim. So that is the strategy we are going to use. So we're going to say kubectl apply. We're going to create the volume first. Okay, so now we need a namespace. Sorry, I didn't. So we need to create a namespace called fraud. Okay, so that namespace is created. So let's make use of okay, so that is it. So we can now say kubectl apply. We're going to say volume. So the volume is created. So if we create, let's create the claim also, apply. So this, we are creating the persistent volume claim. And then the last thing is to create our port. Okay, so our port is PV port. Okay, we're going to run that as well. So we've created our PV, our PVC, as well as our port. Okay, so let's check. Let's check get PV, PV and PVC. Okay, PV for persistent volume, and then PVC for persistent volume claim. So like we can, I need to specify the namespace. So I think I need to specify the namespace as fraud. Okay, so remember also that volumes are not namespaced. Okay, so you see the volume, as we said, get PVC and PV. We didn't specify the namespace, so it was smart enough to know that it's going to display just this one, because that is what we have. It's not just namespace, so it's global. Okay, it exists in your entire cluster. So you see, this is the persistent volume. Capacity is what, 2 gig, and then the access mode is what, read write once, and then the reclaim policy is what, retain, and then the status is what, bound. Okay, we have about 4 volume phases. Okay, we have the available, we have the bound, we have the released, and then we have the failed. So these are all volume status that I can do video on in the future, but just to let you know that we have all these three types. And then the claim is what in this namespace called fraud, and it's called tax PV claim. Okay, so the persistent volume is namespace, is existing in a namespace. So that's why you see this fraud namespace and then the name of the PVC. And then the storage class is manual, reason empty, 57 seconds ago. Okay, so as you can see, the persistent volume claim definition, it's the status is what bound, and is bound to what? Which volume? Tax PV volume. And then the capacity is what? 2 gig. And then the access mode is what? Rewrite once. The storage class, manual, 51 seconds ago. Okay. So let's go get our port as well. Get port inside the namespace fraud. You see, the tax PV port is running, and it's running on this node, okay, 00 node. Okay, we have 2 nodes. The other one is 01, so it's running on just 00. Okay. So what can we do? We have to exec into this. Okay, so we have to exec into this port. Okay, so kubectl exec into bash. We have to exec into this port. So say tax okay. So let me see. Okay, so let me switch into kubectl config set namespace is fraud. And then I'm going to say kubectl get ports. I don't need this namespace even. So let me see if I can exec into it. Exec. Okay, so now I've been able to exec into it to the port. So let me see if curl works here. Okay, I don't think we have anything running. So what I'm going to do here is that I'm going to write a file to, you remember our user share Nginx HTML path. Okay, so I want to write some data to this path. So I'm going to say echo hello GoDataProf. Okay, so that's what I want to write to this file. And then I'm going to call it index.html. Okay, so we can cut this path and then we see what is in there. You can say cut. You see, this is hello GoDataProf. So if I say curl, let me see if this is gonna. You see, if I say curl localhost, is going to print hello GoDataProf because it's running Nginx. Our image that we deployed was Nginx. Okay, so but we are executing this command inside our port. So what if we want to access this information outside our port? Okay, so let me create a vertical. Okay, so I'm going to create, so let me see, kubectl get port. Okay, so we still have the port running. So what I'm going to do is I'm going to forward the, you remember the container was running on port 880. So I'm going to forward this port, okay, from 80 to 5,000. So I'm going to say forward, I think it's forward port. Let me see, ask for help. Okay, let me see if it's, let me check my history. History grep forward. Okay, so it's port forward, okay? The command is port forward. Yeah. So we are going to forward the port from 80, which is the remote, to the local 5,000. And I can use K, but let me type the whole thing. So when we forward the port. So now we are forwarding the port. So let me see, let me split it horizontally. So if I say curl localhost 5,000, you see the output is what? Hello, GoDataProf. Okay, so I can write another echo. I can write echo GoDataProf Kubernetes. Okay, if I do that, and then I say localhost, you see we have hello GoDataProf Kubernetes. So now if I curl this, you see I'm getting the same output here. Okay, so now let's go to our browser and check this IP address, see if it's going to work. So if I say localhost 5,000, you see the output. The output says hello GoDataProf Kubernetes. Let's do one more. Let's write one more thing too. So I'm going to write another thing. I'm going to say it works. Okay, just that. Okay, so I'm going to curl that local host, and then you see it works. So let's go back to our browser. So if I refresh the page, you see we have the output as what it works. So that is all for persistent volume claims and then persistent volumes. Okay, so watch the video again one more time, and I think you understand what exactly what persistent volume and what persistent volume claim is, and how you can mount it inside your running containers. Okay, so thanks for watching. Like and share the video, and don't forget to subscribe. I'll see you in the next one.